All right, so let's go ahead and take a look at the graphs of secant, cosecant, and cotangent. So here is the secant graph. To graph the secant graph, it's actually not as bad as it kind of looks like. One of the good strategies to do it is to be able to graph the cosine curve first. So whenever you're dealing with secant and cosecant, remember I think one of the really good strategies, regardless of whatever the graph looks like, I always like graphing, at least for secant, I like to write the cosine curve first. And then for cosecant, I like to graph the sine curve first. Cotangent's a little just different story. So, because whenever you see this looks really confusing. This is just to give you a little bit of an idea of what the secant curve looks like. So if you look over to the right-hand side, you see what the secant curve looks like. It has asymptotes and it has like parabolas going everywhere. But typically what's happening is that you're basically graphing the cosine curve. So you can see in red, the cosine curve is being graphed. And basically wherever the cosine is going through 0, that's where you're going to have asymptotes. And that makes sense, right? Because we know that the secant of x is just 1 over the cosine of x. And whenever the cosine of x is equal to 0, that's when you're going to have asymptotes. That's why you have asymptotes there. And then what's happening here, right after you locate the asymptotes, you can see that, notice that one piece of the graph, let me just color it in yellow. Oh gosh. So you can see that one portion of the graph kind of looks like it's doing a humped downward. So what you're doing is you're basically just flipping it upward. Okay. Let me use this instead. So let's see how this is going downward. So basically the reciprocal or the secant graph will just go upward. And that's basically what's happening here. This one's going smiley face down to a sad face. Okay, so that's why it's useful to graph the cosine curve first. Graph everything that you need to do without the vertical shift. Flip everything, including your asymptotes. So here, couple of key features. The stretching factor is absolute value of a. So if you have a or amplitude, there actually is no amplitude here. That's what it will be. The period is back to being 2 pi over b, so same thing. The domain for the secant curve is everywhere except where the x values are not equal to pi over 2 plus pi k, which is very similar to the tangent curve. The range, notice that in the range, there is nothing where you have these humps. So you can see here when we flipped everything, there is nothing in the inside of this graph. So it'll be from negative infinity to wherever the negative value of a is, union a, all the way to infinity. Again, there's no amplitude, and the secant graph is even because the cosine graph is even. Okay. So now taking a look at graphing it. Okay, so to graph the secant curve, you need to find the cosine curve first before any vertical shift. So we're gonna graph the cosine first, and then before doing any vertical shift going up and down. We're going to flip the graph and locate the asymptotes where the cosine is 0, and then do any vertical shifts if necessary. Okay, so that's what the secant graph will look like. Now the cosecant graph, which kind of looks like this, it's going to look a little different because remember that now cosecant of x is just equal to 1 over sine of x. So now you're going to have asymptotes wherever sine of x is equal to 0. Okay, so if you look at the sine graph in red, you can see that wherever it crosses the x-axis, that's where you have your asymptotes. Okay. Now, same thing as before, you see like a little bump here. Okay, a little sad face. To find the cosecant curve, you're just going to go upward. Okay, so just flip it over. And this is just a more general view of what this looks like. Okay, so again, same thing, some key features of the cosecant graph, right? Stretching factor is absolute value of a. Period is still 2 pi over b. You can see the domain is kind of shifted over pi over 2 units, so that's why x is everywhere where the asymptotes will be where it's equal to pi k. So every pi units, you end up getting an asymptote. The range is the same as the secant curve. There is no amplitude. And because sine was odd, cosecant will be odd. Now, one key thing about this is that this will be considered one period. So if you look at this part from here to here, this is one period. Okay? Because then it starts repeating this pattern afterwards. So even though the equation of the asymptotes is every pi units, that's where the asymptotes are at, it completes one whole period every 2 pi units. Okay. Again, to graph the cosecant curve, you need to make sure that you graph the sine curve first before any vertical shift. Okay. All right. So let's go ahead and do some examples so you guys can see what this looks like. So let's start off with graphing y equals 3 secant 2x plus 1. All right, so I see no phase shift, which is really nice. So one of the things that I want to do first is let's change the secant to the reciprocal, which is cosine. So instead, I'm going to graph 3 cosine. Let me put up arrow. Cosine of 2x plus 1. So let's take care of the period first. So my period is going to be equal to 2 pi over the absolute value of b. So in this case, b is 2, so you get 2 pi over 2, which gives me pi. So that means it's going to complete one full cycle at pi. All right. So remember, my cosine, we start at 0 and it's going to end at pi. So now we're back to the nice ones. So we don't have to deal with the tangent. The tangent was terrible, right? Because you had the pi over 2 and it's just really weird. But now we have 0 all the way to pi. We need to figure, so this is where, so it starts at 0 and it ends at pi. We need to figure out all the middle points. So halfway between is pi over 2. Halfway between 0 and pi over 2 is pi over 4. Halfway between pi over 2 and pi is 3 pi over 4. So just finding the midpoints again. All right. Now we can do this a little faster now. So that was the stretching component. So that was a period change. Now with the 3, you know that this guy's going to go up 3 units. There's no flipping. So we just got something that looks like this. All right, so remember, cosine starts at 0. I'm sorry, at 1, which now got switched over to 3. Then 0, negative 3, 0, 3. So this is what the cosine curve looks like. All right, so we graph the cosine curve before we do any vertical shifts. So we're not going to do any vertical shifts yet. And now what we're going to do is let's locate the asymptotes. Okay, so our asymptotes are going to be wherever this crosses the x-axis. So this crosses the x-axis here at pi over 4 and also at 3 pi over 4. And now all that we're going to do is we're going to just flip everything around. This is going to flip up. This is going to flip down. This is going to flip up. So let me go ahead and make it a little nicer. And what we're going to do is we're going to ignore the cosine curve now, because the cosine curve was basically just there to help us out, or help us figure out what the curve was going to look like. So asymptote at pi over 4, asymptote at 3 pi over 4. At 3, I'm going to be going upward. At pi over 2, I'm at negative 3, and I'm going to be going downward. And at pi, I'm also going to be at 3, and I'm going to be going upward. Okay, so now that we have something that looks like that, now we can do the vertical shift. So now we can go ahead and do that +1. And that +1 is just going to shift it up 1 unit. So shift up 1 unit. Okay, so now you're going to have, I'm going to write -1, -2, 1, 2, 3, 4. Then we have 0, pi over 4, pi over 2, 3 pi over 4, and pi. So we're going to have our asymptotes at pi over 4, asymptote at 3 pi over 4. Everything's going to be swapped up 1 unit, so now this guy's at 4. Swap up 1 unit, now I'm at -2. Swap up 1 unit, now I'm at +4 again. So my graph is going to be all of this. That looks really ugly, but here we go. That's my graph right there. Okay. So now let's take a look at this cosecant graph. All right, so now we have a period change and a phase shift, a flipping of the graph, amplitude or the scale factor of 4, and then going down 1. All right. So let's go ahead and change this to a sine function. So -4 sine of 2x minus pi over 4 minus 1. So we switched it into a sine graph. Now let's make it into correct phase shift and then period change. So -4 sine, I'm going to take out a 2, so I get 2 times x. Factoring out a 2 is basically dividing by 2. So this is going to give me pi over 8 minus 1. All right, so now let's start off with my period. So what will be my new period? So my new period will be 2 pi over b, which is 2 pi over 2, which again, it gives me pi. So it'll complete one full cycle and pi units. And you can see now that my phase shift is going to be pi over 8. So basically what I'm going to be doing is doing the opposite of what this tells me. So I'm going to be adding pi over 8. Okay. So right now, my starting point will be at 0, and my ending point will be at pi. Because instead of going from 0 to 2 pi, now I'm going to be going from 0 to pi. Okay, that's my new period. And now all I got to do is shift everything pi over 8 units. So I'm going to add pi over 8. Okay, so now I'm going to add this pi over 8. So this is going to give me pi over 8. And now I'm going to take this pi, that's going to give me, I think, 9 pi over 8. Okay, so this is where I'm going to start. This is where I'm going to end. Okay. So I'm going to graph this. So starting at pi over 8, ending at 9 pi over 8. And now I'm going to find the midpoints. So I'm going to have to look at all the midpoint. Okay, so halfway between pi over 8 and 9 pi over 8. So this is, I'm going to do it offline. So since we've done it so many times. So pi over 8 plus 9 pi over 8. And then I'm going to divide this by 2. I'm going to get 5 pi over 8. And then what's going to be halfway between pi over 8 and then 5 pi over 8 divided by 2. That's going to be 3 pi over 8. And then the other one you can verify this is going to be 7 pi over 8. Okay, so just taking the midpoints. All right, so now we figured out, we got the middle part completed now. There's a scale factor of 4, and it's a flipping of the sine curve. Okay, so this guy's going to go up 4 units. -4, and there's a scale, and it's going to be swapped. So instead of going, and we know that the graph looks kind of like this. So if I'm flipping it, it's going to now look like this. So it's going to be 0, -4, 0, 4, 0. So again, knowing the parent graph is super duper important. Okay. All right, now we flipped it and we did the multiplication of 4. Now before we do the -1, let's go ahead and find the vertical asymptotes. So that's going to be wherever it's 0, so at pi over 8, and at 5 pi over 8, and at 9 pi over 8. And what I'm going to do is now flip the graph. So this is going to go downward, this is going to go upward. Okay. So let me graph it a little nicer. Okay, pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, and then 9 pi over 8. Asymptotes, and then my graph, downward, and then upward. And now finally, let's just go ahead and shift down 1 unit. So this is going to be 1, 2, 3, -1, -2, -3, -4, maybe -5, pi over 8, 3 pi over 8, 5 pi over 8, 7 pi over 8, 9 pi over 8. All right, and now everything's going to be shifted down 1 unit. So this guy was at -4, so now it's going to be at -5. And the other guy was at +4. I'm going to shift down to 3. So it's going to look like that. All right, and that is my answer for this one. So lots of work, but that will be it.